Hello, everyone, and welcome back to our November edition of our live stream. Thank you so much for being here. For those of you who don't know me, my name is Jace, and I'm the founder here at AirWeights. We have an exciting show for you tonight, a topic that's been heavily requested by a lot of the people in our community and users using our products. So excited to get into the topic tonight. If it's your first time here and you've never attended one of our live streams before, please let us know in the chat. We'd be glad to welcome you. I've seen some great familiar faces here. Jambox CNC, Chris, even my mom's here. I mean, imagine that. So what are AirWeights? Who is AirWeights? AirWeights is a manufacturer, Colorado-based, of modular vacuum tables and work holding equipment. We make all our products right here behind me on the machines that you see. And we're very proud of the product that we produce and the quality that we're able to offer and the solution that our customers get to use. So that's AirWeights. If you have not already done so, we would greatly appreciate it if you would subscribe to our YouTube channel. You can find the subscription button on our page at AirWeights. And we would also love it if you're interested in subscribing. Please subscribe to our email list also. That's where we post, or we let people know about sales, all the new products we have coming out, and that's the first list that we hit with new information. Even the sale that we're running right now was actually advertised as an early offer to our email subscribers first before we posted it anywhere else. So if you're interested in that sort of thing, discount sales, new products, early bird access, and just what's going on in the shop in the future, please subscribe to our email list. So tonight's topic is repeat locating. And this is something that I'm really excited about talking about because it's such an important part of CNC, and understanding location is just critical for having really great projects. So just a quick outline of what you can expect for the evening. We're going to talk about how to create a repeatable location using all three types of work holding approaches that AirWeights offers with our products. So that'll be direct mount, workpiece right on the vacuum table, Spoilboards using an MDF layer as a sacrificial surface, and then fixture plates, which are more of a dedicated vacuum fixture approach. We'll do a live Q&A, and just as I'm mentioning that, if at any point during the show a question comes up for you, please just post it in the chat. Kate's in the background, our operations manager. She's flagging questions, and we'll bring those up during the live Q&A, and you can get direct answers right from me, straight from the horse's mouth. So yeah, make sure you enter your questions in the chat. After the chat, or after the live Q&A, we'll do a giveaway. We always do a giveaway on our live streams, so great opportunity to win a system. Last time we did a giveaway, the winner was from Canada, and we ended up with a pretty odd situation with tariffs and import tax and stuff like that. So unfortunately, for the time being, we are limiting our giveaway to US only. So just wanted to note that. If you happen to be Canadian, we'll do another drawing, but please email us anyway and we'll work something out. And then we'll wrap up the show. So that's kind of the outline for the show tonight, and I'm excited to get into the content. But before I do, I want to just take a moment to acknowledge our team. So I'm the founder here, Jace. I have a co-founder, Jeremy. He does a lot of our website stuff. If you guys like the product photos and some of the videos that are out there, a big shout out to Jeremy, co-founder. I also want to acknowledge Kate, our operations manager, who's in the background right now. She makes the whole ship turn and work, and does a lot of stuff. So a big shout out to Kate for all her hard work. Couldn't do it without you. I also want to give a shout out to Alex, our production technician, lead production tech. He's been doing an incredible job getting things done, making tables at an alarming rate because we have our sales been pretty successful. So huge shout out to Alex for all his hard work and dedication. Thank you so much. And to Carrie, who's now helping out with fulfillment and shipping. She's been doing a great job learning really fast and getting up to speed. So that's our team, and I just wanted to acknowledge them. Without them, none of this could happen. And really happy to have such an incredible group that we can support more customers at a really high level. So thank you to all of the team. So let's dive into the content for tonight. Location, location, location. So knowing the location and orientation of your workpiece is critical for CNC projects. You just have to know that. And there's a lot of ways to get there. People use touch probes or plates. People have established references that they use as their origin for every single operation that they run. And vacuum work holding can really help you in a lot of different ways understand your location. And we're going to go through a lot of different examples of that tonight, just so that it gets the juices flowing for you and brings some ideas up about how to use your system and make sure you have a stable reference in terms of location for a lot of your projects. So the primary thing that a vacuum table does is create negative pressure underneath your workpiece. And then as a result, the entire atmosphere pushes down on your workpiece. So a vacuum table does a really good job of helping in one direction. That's Z. It pushes your material down. And it creates a uniform distributed pressure difference between above your part and below the part. And that's really key. Like if you use screws or even double-sided tape or any of the other work holding methods, clamps, side pressure, toe clamps, you can end up with uneven pressure on your workpiece. In other words, you might be held down really firmly in one location, but without distributed pressure across your workpiece, you can end up with material that's not sitting flat. It'll change your depth of cut in the resulting part. So there's a lot of advantages to having that uniform distributed pressure holding your part down. So that's the first thing. But to do this correctly, to operate a CNC really, really well at a high level, you got to have more than just Z. You got to know X, Y, and your rotation. So one of the most common ways in machining to accurately locate your part is to either touch off or create a reliable hard stop that you push your material against and that you're able to get back to repeatedly. So we're going to be going over how to create repeat stops with all three of the work holding methods that we offer. I'm not sure if you guys can hear that, but there's a compressor running right now. I hope you can't hear it too loud. Hopefully it'll go off pretty soon. Forgot to turn that off, sorry. Anyway, so we're going to talk about how to create a reliable, hard location stop, a repeat stop with all three of our work holding methods. And the three methods that we offer to customers as the primary methods for using the AirWeights work holding system are direct mounting, where the workpiece is directly in contact with the top surface of the vacuum table. We also offer spoilboards, which are basically a porous membrane of MDF that sits right on top of your vacuum table. Give me 1 second, we're just shutting the compressor off. And then also we offer fixture plates, which are a non-porous layer that sits on top of the vacuum table and allows you to cut completely through your part into this non-porous membrane when used with some gasket material. So those are the three methods: direct mounting, spoilboards, and fixture plates. And we're going to show how to create repeat stops and repeat locations that you can reference again and again using those three methods. So before we do some of the demos and show how to do that for each individual method, I want to just talk about what each one of those methods is good for. So most times it can be deduced right down to the material that your project is made out of. So for example, our direct mount method and our fixture plate method work really, really well with hardwoods. Our tile gasket and MDF method, the downdrafting method using a spoilboard, works really, really well for non-porous sheet goods. And between all the different approaches and different things you can do, you can mix and match and create a reliable work holding approach for a very wide variety of stock materials that are out there and available to you to process with your machine. So, direct mounting, think hardwoods, pretty much any material. It's the most direct and most uniform and most accessible method right out of the box. I encourage people to start here just to gain an understanding of how vacuum work holding works. And we'll show a quick demo of that. But hardwood boards, even sheet goods, as long as you're not cutting completely through your material and into your vacuum table, which you don't want to do, this method is extremely reliable. So great for engraving projects, great for customization, great for getting your feet wet and just starting to use the table and get a feel for how strong vacuum work holding can be, and get a sense for the amount of force that you can actually achieve with vacuum. Spoil boards are great for smooth, flat, non-porous materials. I can't tell you how many times I've said those 3 words in this live stream, but I say it again because it's so important. You are not going to be able to hold, you know, a little 6x6 piece of hardwood on a bare spoil board. It's just not going to happen with our system. So things like melamine, pre-finished plywood, sheets of plastic, Bamex, you know, aluminum, thin aluminum sheet stock. Those are all great for bare spoil boards. And you want to make sure your part size, your finished part size, is relatively large. And if it is, you can cut through your material and just skim your surface of your spoil board and leave a finished part with no onion skin or tabs. Same criteria for MDF and tile gasket. You can cut smaller and smaller parts, and you can also account for a little bit more surface roughness. So you can have a large Baltic birch, sanded Baltic birch sheet that's nice and flat, throw it on there and cut out a relatively large part, no problem. As you get smaller and smaller, you need the surface finish to be really nice and smooth so that you can hold that material down, making, you know, great contact with the entire surface. And the other thing I want to say about spoil boards is it's really a sheet good processing technique. It's not meant for individual pieces of hardwood in the same way that a fixture or direct mounting is. And then fixture plates are another product that we offer. It's basically a non-porous sacrificial surface that you lay on the vacuum table. We'll talk about that in a little bit. They locate with pins. You can put them on, you can take them off and put them on in the same position every time. And you can set them up for production or just anything that you, there's a lot of creative ways to do it, but anything that you would like to use often, I guess I'll say. So, you know, you could establish a corner reference on a fixture plate and change out the gasket frequently to account for different shapes and sizes, cut all the way through into the fixture. So there's a lot of different ways that you can utilize a dedicated vacuum fixture by customizing one of our fixture plates and adding some of our gasket material. So we'll go over all those in a little bit more detail, but I just wanted to outline when you should use each one of those. So smooth, flat, non-porous materials, spoil boards if it's a large part, tile gasket if you're starting to get smaller. And then if you're really small, dedicated vacuum fixture with cover gasket. And then if you're just engraving something, direct mount right on the vacuum table, super direct, super easy, and we'll show a demo of that in just a minute. So those are all the ways in which we recommend using our system based on material. So I just wanted to highlight that. So let's talk about how to create a stable location, a stable reference in the XY plane for a given component. And I'm going to bring you over to the machine now and show you some of the demos that I have set up. I've been trying to buy another one of these cameras, and I just cannot find them in stock anywhere. So bear with me while you come over. So here is our machine. I'm actually going to spin you around so I can see a little better. Ew. Okay, so this is our Onefinity Elite Foreman. We manufacture quite a few vacuum tables on this thing, and we have 4 individual 24 by 24 vacuum tables on here. So underneath each one of these accessory layers on those 3 positions is a vacuum table just like this. So recently, not that recently, but a while back, we came out with these hard stops. They're precision machined aluminum stops that nest into the grid of the vacuum table. And what that allows me to do is basically slide my workpiece up to a repeat stop. And when it hits that stop, I'm defining, you know, one plane using these 2 stops and then just one more on the other edge, and that gives me a stable corner. This corner, because of how our vacuum table is designed, I know is at the coordinate of 7 in X, because these are all 1 inch, 7 in X, and 8 in Y. So if I center this on a 24 by 24 area, I know from this front left corner, you know, like 24, 0, I can get right to that corner at exactly 7, 8, so to speak. If I turn on the vacuum table now and I turn on the pump and I suck this thing down, hear the pump kick on more than likely, and now this workpiece is, whoops, What happened there? Wrong one. Yeah. There we go. Had the wrong valve open. So now this workpiece is extremely rigidly held, can't move it. And I could come and machine this, do whatever I want, as long as I don't cut through the material into the vacuum table. So this is extremely valuable for having a stable reference. You can butt material up to, you can run an engraving project. And then when you're done, you simply kill the vacuum, turn the pump off, and release pressure. And then that thing just comes right off. So that's using our hard stops and grid gasket in the channels of the vacuum table. It'll suck the workpiece flush with the top surface of the vacuum table as the gasket compresses into the channel. And one of the other nice features I wanted to highlight is that we are just in the process of validating and releasing our new flush mount vacuum plugs. So these are a new product that will come standard with our systems. And our old plugs, they used to sit above the surface. They'd sit proud. These now sit flush with the table surface. So if your workpiece were to overhang a plug and your gasket region was actually inside that plug, the workpiece would not interfere. This also allows you to use our accessory layers on top of the vacuum table and partition off the grid underneath to isolate flow to a smaller area. So some nice benefits there. The other thing that's coming, just while I'm on the topic, is our new slot washers. So these are stainless steel slot washers. They fit into the slots of our vacuum tables, and they will also come standard and drop right in here so that when you fasten the vacuum table to the machine, you get a nice repeatable torque. So that's our first kind of setup, is creating a repeat location using hard stops and grid gasket on a direct mounting method right on the vacuum table. The second thing I'd like to show is using a Spoilboard to create a repeat location. So in position 1 of this machine, I actually have a fixture plate that's sitting on top of an MDF Spoilboard with tile gasket on it. So you can see there's tile gasket underneath there and an MDF Spoilboard. And I also have some 3/4 inch long pins that are going through the entire stack from the fixture plate through the MDF into the vacuum table. So this whole stack up is actually located relative to the vacuum table. And the reason I'm doing that is today we're actually going to make a fence. So we're basically going to take this fixture plate and cut a profile right here with a known offset from our origin. And we're just going to separate an L shape from this bulk material. And we'll take that off, and then we'll have an established corner reference that we can use to put material up against and hold in place. So we're going to do that just in a second here. I'm excited to show that to you, and I think it's something that a lot of people will end up using. Similarly to this setup right here, you can also use a bare Spoilboard to create a repeat location using dowel pins. So on this, you can see that I have 3 steel dowel pins in a similar orientation to these 3 hard stops. And if I take this piece and put it up against these dowels, and I push it to the side, now I have my material squared and located relative to my machine. You'll notice that if I turn on, actually let me take this off for a second. If I turn on the pump, I push down. So now this is active. I can feel a little air sucking through the MDF. And a bare Spoilboard, like I said, you got to have some significant area. This is not going to hold a piece of MDF that well. It's sticking a little, but it doesn't really get you much. But if I just put a nested gasket square, another one of our products, on here, and I get this thing off, and I butt it up to this corner, so 1 reference, 2 reference, and seat it, now that thing is rigidly held. I can't move that because there's a vacuum pocket underneath there. So another quick and easy way to create a reference, just drill some simple holes, not going all the way through because you want to not hit the vacuum table underneath, but 3/16 deep in our 1/4 inch spoil board, and you get a stable, repeatable reference that you can butt material up each time. So I will turn off the vacuum pump and release pressure there. And again, that just comes right off. So yeah, again, just to demonstrate that one more time, this is a good example of just a quick and easy setup. This is our onboard gasket. If I turn that position on again, here's a piece of oak, and hardwood board. It's pretty rough on one side, smooth on the other, but still, even with that, I don't get any suction there. Little loop of onboard gasket with the hardwood. And if I put that on there and push for a second, hey, there we go. Now it's just totally rigidly held, and I can come and cut through outside that seal and just skim the surface of the spoil board, and thing is on there. Don't have to worry about onion skins or tabs. So shut that off again and pull that off. So again, hardwoods, you want to use direct mount, a fixture plate, or some onboard gasket on top of your spoil board, and that'll do you right. And then the last application that I want to talk about is using a fixture plate, and a technique that I've used a lot in industry manufacturing parts for customers in the past. This is one of our fixture plates. It's located with pins. And all I did here is create a recess and then put another one of our onboard gasket squares, same material, poked a hole in the center. And what that allows me to do is then place this material into the cavity and push it up to a reference. So I'm essentially making my own fence, but for a smaller part. So again, if you were customizing something and you wanted to be able to engrave in the same position every time, this is a known offset from my vacuum table, and I can get back to that position every single time, just reload and repeat. And the other thing I'll say about this is if you're really running production, however many positions you can fit on a fixture plate will really optimize your throughput and make sure you can get back, you can customize as many parts or finish as many parts doing roundovers or what have you at the same time. So let me turn on that position, turn the pump back on. And so I can already tell just by the sound it's on there. And I very intentionally left some space here. You see there's space all around just to make sure I could drop the part in and butt it up to a corner, but also to show that I can't slide that thing out of there. So very rigidly held, very repeatable, and a really nice approach to getting a repeat location for a given setup. You could do the same thing with a wider area, which is very similar to what we're going to demo on our tile gasket here. But that would allow you to customize and just lay down gasket for whatever shape or size part you have. So there's quite a few different ways to get back to the same position over and over again. And a lot of it hinges on the fact that our fixture plates and spoil boards have holes, and 2 holes in the front, 2 slots in the back for repeatedly locating those accessory layers on the vacuum table where they're machined. And that allows you to take those layers off, put down another layer, and run a different program with a different fixture. So the system that that has locating pinholes in the vacuum table and then mating holes in the accessory layers really allows you to have a library of vacuum fixtures or setups that you use most commonly. So that's what I wanted to show in terms of all the setups that we can offer. Let's do a quick demo so that you can get a better idea for how to create a repeat location on a spoil board and tile gasket, making your own fence. So the required materials for what I'm about to show are an MDF spoil board, tile gasket. You can buy those pre-applied, or you can buy them individually, and then one of our fixture plates. And that'll allow you to make a fence on top of your vacuum, on top of your tile gasket that you can just butt material up into. So I'm going to go ahead and make that now live. So what I'm going to do is I'm going to adjust my manifold so that position 1 of my vacuum table is active. I'll turn on the vacuum pump. I already have the tool zeroed to the top surface of the material. I've measured it. It's about 0.24 thick, and I'm cutting through by just a little bit, about 10 thousandths. The idea there is you want to just barely skim the surface of the tile gasket. You don't want to cut into it too deep because you'll create escape passages for air to flow out. So I'm going to turn on the vacuum pump. I have my origin set at my machine origin, and then I have this little profile pass. We're just going to cut this fixture plate and take the excess material away. And then we'll show you how you can butt material up into that corner and get back to the same spot every time. Just have a stable reference. So let's go ahead and do that now. So I've got all of the valves on my manifold open except for this front position. I'm going to turn on the vacuum pump and we'll run the file. So pump on. This is held down. I can try to peel it up and it doesn't really. There we go. Doesn't come. So I'm just going to load the file. Just a very simple profile cut, and should be good to go. If it doesn't work, don't hate me. I have not validated this. This is all on the fly, so bear with me. Dust collection on. It's going to be loud for a minute. And this will be a full depth pass, 200 inches a minute, the 1/4 inch low helix upcut. All right, so super easy program. I'm just gonna leave this pump on for a second, bring you in and show you just what we did. So we had a fixture plate located on top of this thing. And basically, all we did was make a cut right here. You can see I cut through just barely skimming the surface of the tile gasket. You can see those exposed holes of the tile gasket. I have a little corner relief here to make sure that if I have a sharp corner, I'm not going to interfere, and then just came out along here. Now, this is now effectively a fence, this piece, and it's located with pins, so I can take it off and put it back on at my leisure. And if I shut off the pump, I have this excess material now. It's bleed pressure. I'll take this right off. So now I have a corner reference on tile gasket. And what that will allow me to do is say I have a workpiece, something smooth, flat, and non-porous, like this piece of acrylic, and I put it into this corner. Whoops, you couldn't really see that, could you? If I put it into this corner like so, yep. Now I have a stable reference that I can use to locate my material on top of tile gasket. I turn the pump back on. And after a minute, can't slide that at all. I mean, acrylic holds incredibly well. And as an example, so does pre-finished plywood. So, you know, you could butt that into the corner and use that to make your part. So lots of different ways to establish a corner reference, regardless of whatever method you're using, whether you're using your direct mounting on the vacuum table by itself, you're using a spoilboard with tile gasket, a spoilboard with onboard gasket, or a fixture plate. There's always a way to establish a repeatable reference, regardless of whatever methodology you're using. So I think that's a really important thing to note about our system, and something that has not been obvious to a lot of people. So that's what I wanted to share tonight. And I think that'll conclude our demo for the evening. So again, just in summary, direct mount and fixture plates or onboard gasket on top of a spoil board works awesome for hardwoods. If you want to just engrave something, you can just set up some grid gasket and some stops for direct mounting. If you want to create a location, you can use pins, you can use a recess, you can make a fence using one of our fixture plates, you can make a fence using whatever material you have around. The DXF for all of our vacuum tables, they're all available on our website for you to download and use to create all kinds of custom jigs and fixtures for your specific projects and your needs. So there's always a way to get a location, and yeah, that's what I wanted to share tonight regarding demos. So from there, I think we are going to transition to our Q&A. So Kate, if you wouldn't mind, please bringing up some of the questions, that would be wonderful, if there are any. All right, PCTATC. Oh yeah, we've been emailing. Jace, what are the advantages and disadvantages of the AirWeights complete system 48 by 48 2-zone versus 4-zone? Great question. So this is a very common question that we get a lot in our inbox, and I'm glad you're asking it here because then I can link people to this video. So basically, I recommend going 2-zone if you process full sheets of material very often. The reason for that is that it has less gaps between individual zones on your complete machine layout. And less gaps means more work holding potential if you're just using spoil boards or spoil boards with tile gasket on them. And the major advantage is just that you have continuity. There's only 2 zones, a front and a back, typically the way we have ours set up to be used, and that just eliminates the gaps where you would have no work holding strength. The downside is flexibility, modularity, and basically repairs, I guess I'll say. So if you have 4 individual zones and you damage one, pretty easy to replace just one. If you have 2 zones and you damage one, it's a more expensive repair. The other thing is that you can isolate flow to a much smaller area and increase your work holding force in that zone compared to being able to only isolate it to something that's double the size. So if you do a lot of small parts, or you'd like the flexibility to be able to isolate flow down to much smaller areas and really push the limits of what our system can do, the 4-zone is for you. If you're processing melamine sheets all day, 2-zone, or plywood sheets or whatever. If you're taking 4-foot by 4-foot sheets and putting them on your CNC and cutting them, the 2-zone is the way to go. Next question. John, will Spoilboards tiles work with leather and a drag knife? Great question. The answer is yes. The truth about this is you really need the leather to be smooth. So if it's really, if you have a smooth side on the stock material, you want to put that side down against the vacuum table. I do not recommend using tile gasket with that material. It's kind of like a gasket as it is. And the other thing that you want to make sure is that you're covering up any unused area on the spoil board. Tools Today recently did a great demo of this, and it's on their Instagram. It's also on YouTube. I encourage you to check it out if you're interested in using a drag knife for cutting leather, especially for prototypes and one-off things. But basically, they just, they had an odd kind of shaped piece of leather and then just took Oromask and cut a piece of it to cover the unused area. And that just helps seal up all the aggregate leak that would otherwise be just, equalizing to atmosphere. And that improves the work holding strength on the leather piece that you're looking to cut. So ideally, you cover the whole spoiler board. If you can't cover the whole thing because your material isn't big enough, cover the excess with non-porous scraps, plastic, marker board, melamine, whatever you have around that you can cover up that extra area with. Any estimated release date for washers and flat pins? So I'm guessing you're talking about the plugs, the little flush mount plugs. Yeah, so it'll likely be in the new year. If you recently ordered, it's not going to be a part of the current orders. We're just still validating we have a little bit of feedback that we gave on the mold for these plugs to make sure that we're completely dialed in and sealing really, really well. We really value sealing performance. I mean, every single vacuum table that we have that leaves this building is tested under vacuum and meets a very strict spec for pressure decay. So, you know, sealing is important to us, and it's kind of how our products work and function, given that we use lower flow rate pumps that prioritize depth of vacuum over flow rate. So we just have a little bit more work to do on those, but they'll both be standard starting in 2026, likely as early as late January, early February. Coda, are those the design I sent? No, these are they're close, but they're a little different. We did do our own design from scratch. I appreciate you sending those, Coda, but these are a little bit different. Fishkeeper, what is the difference between the adhesive gasket and onboard besides the thickness? Nothing. They're the same exact thing. It's just one is a 16th, being the onboard gasket, and the adhesive gasket is an 1/8 of an inch thick. The adhesive gasket, the nomenclature we chose is a little bit confusing, admittedly. We were trying to like kind of just make it more general, but then I essentially pivoted back to All-Star CNC's nomenclature because it's sort of the industry standard. So there may be a name change coming around that. It's really the adhesive gasket for us, we utilize as an inboard gasket. An inboard gasket is recessed into a channel, and there's just a little bit of purchase sticking up above the surface of the fixture or vacuum table. And when the workpiece is sucked down, it comes into intimate contact with the surface that the channel is cut into. But an onboard gasket just sits right on top, which I was demoing back here. Those are all onboard, super easy to use, 1/16 of an inch thick. And because it's thinner, it doesn't have that jiggle or wiggle that thicker materials have. You know, we'll get a little compliance if the gasket is too thick. So really clear and direct and easy, but your stock material has to be rigid enough to account for the fact that there's literally a void underneath there. Like 3/4 inch material does pretty well. You get below like 3/8 and you'll start to see the material kind of sag in the center unless you have little support bridges of onboard gasket underneath there. So thin stuff, you know, can be really nice to just cut a channel in and recess the gasket in, provide some airflow channels between. But really, there's no difference. You know, all of our gasket materials come from All-Star CNC products. They're our partner, and you know, we're a reseller of their product. So you know, for them, it's a much more industrial application. Same material, same adhesive. It's just a different thickness, essentially. Are there any holes, notches, or known in the vacuum plates that would aid in alignment with 20mm dog holes in my Spoilboard? Or should I just use the 3 dowel method for alignment? Good question. Not known. Our vacuum tables are admittedly designed in Freedom units, Imperial, and 96mm on center spacing doesn't quite work out in the same way. But we did recently release what we call the MFT vacuum clamp in partnership with VacuDog. If you check out our previous 2 live streams, you'll see what that product is like and what it's used for. It's a pure vacuum clamp, 2-sided, sucks itself down to the table it's sitting on and holds the workpiece on top. 2 independent zones. Can be partitioned in our grid system, sucks flat through the stack up, hard contact all the way, just like our vacuum tables, and has some features that allow you to mount some bench dogs in, and then it drops right on to 96mm on center spacing with 20mm dog holes, which is important. So check that out if you haven't seen it yet. It's been a fun product for us to break into vacuum work holding off CNC machines. John, for thin materials like engraving plastics, does it help to add a channel gasket in the field to minimize flexing a bit? Yeah, so 2 ways to go about this, like I just mentioned. If you're using onboard gasket with thin materials, be cautious. You want to have basically your loop of gasket and then some support bridges that'll minimize the deflection between supports. If you just have a loop and you have a thin material, it'll totally collapse in the center because there's so much pressure from atmosphere trying to, pushing down on that part, it'll actually flex the material. So add some support bridges in there if you're using onboard gasket. You don't want them to go all the way across. Just, think about it like little islands in there to keep pushing up, just like the grid pattern that's cut into our vacuum table. The other way to go about this for thin materials is to use an inboard gasket approach, and that's with what's advertised as adhesive gasket on our website. You'd cut channels. I actually have you cut channels into a fixture plate. So here's an example. The gasket is recessed into a channel, and there's only a tiny little bit of material sticking up above the surface. And this pulls the workpiece into contact with the surface of the fixture. And then all these channels just promote airflow to equalize pressure within the cavity so that you don't seal off right at the opening right here. So if you have thin material, this works really well. These channels are 1/4 inch wide, so just a 1/4 inch bit, and they're 85 thou deep. You can mess with that depth, and the amount of compression that you need based on the material you're cutting. So if it's something that's really, really soft, you don't want to have too much compression because it'll start to flare up at the edges. You can get just a tiny little bit of purchase and dial in your gland depth to make sure you're just compressing the gasket. And if you have a little bit more thickness to work with or more rigidity, you can have the purchase be a little bit more, and that'll help just grab the part regardless of flatness. So I love that method. That's actually how I got, that's how I made my name in the vacuum work holding space, working in private sector stuff, was these fixtures where I'm sucking the workpiece down into intimate contact with the surface that I machined on my CNC. So it's fixture design and fabrication at a level that allows you to achieve extremely tight tolerances. Chris, do you provide the DXF file for that? So I'm guessing you're talking about this thing we just made. If you want it, you can have it. It's very simple. You just take a fixture plate, and I have a 2-inch offset from the origin. Let me just get it off here. The pins are very tight. But now I have a square. So all I did was go 2 inches in and cut down and make a little relief and cut out. If you want the DXF, I'll gladly give it to you. I'm pretty confident knowing your skill level that I think you could do that by yourself. But if you want it, just email me. John, does this allow two-sided carving? Yes. So the only thing you got to think about with two-sided carving is if you have, I was talking to a customer today about this actually. Like, say you have a tray and you pocket out a huge interior cavity. Like, if this is a tray and this goes, down, and you have a huge pocket in here, and then you flip it over, the work holding force from vacuum can be so strong that you will collapse the wall thickness in the center. So sometimes you just have to be cognizant of the order of operations. In other words, you might be better suited to cut out the profile with the bottom side facing up and then flip it over, locate it, and machine the top side pocket, just so that you don't end up with a big cavity that's subject to collapse when under vacuum. So you can absolutely do two-sided carving, especially if they're flat projects or you have a lot of area to work with. The more complex geometry you have, or the more peaks and valleys and pockets and things like that you have, you just need to be cognizant of the order of operations to make sure you're not going to collapse the part, damage your project. And then yeah, I mean, it's very common for people to be able to, like for epoxy work, for example, they take something off the CNC, do a pour, put it back on, phase everything off, make another pocket, pour it in. Getting back to the same spot's really important in that way too. But yeah, two-sided carving is one of the main reasons that I wanted to talk about this today, is because so many people ask how to do two-sided carves, and all you need to do that is a repeat reference. You need a stable reference that you can push the material into, or somehow locate the material. You can do it with holes in the holes in your workpiece if they're outside the geometry of your finished part, that then flip over onto pins in the fixture plate. I mean, that's how we make all our vacuum tables. We use the pins in our tables to locate the tables for side 2 when we machine them. So it's absolutely possible. There's a lot of ways to skin the cat. And if you want to bounce ideas around, feel free to send us a note. I'm having a difficult time understanding how far off the auto zero for my machine is from my board X0, Y0. I use hard stops, so it's repeatable. But how do I decide how far are they off? Good question. So we touched on this a little bit. I'm assuming that this is using our vacuum table. And the key to that is in the setup of your table. So when you first get your vacuum table, you should watch an installation video, download our DXF, drill 2 holes for locating pins. You place the pins in, and then you place the vacuum table onto those pins. And when you do that, you've now precisely located your vacuum table wherever you drilled the pinholes. So you want to choose that location carefully and make sure you understand where it is so you can always get back to it. I highly recommend centering your vacuum table on a 24 by 24 area or whatever the nominal size is. Our tables are undersized by 1/4 of an inch to account for material yield, and the design is based on the nominal size. So I touched on this previously, but if you look at our tables, if you had a theoretical box around the table that was 24 by 24 on this table, I can go to the center of each square and know I'm a 1-inch increment away from the edge. So this repeat location that I have set up is 1, 2, 3, 4, 5, 6, 7 over an X, and 1, 2, 3, 4, 5, 6, 7, 8 up in Y. So as long as I know that, I can tell my machine, hey, I'm setting my zero, my zero position at 24, 20 X24 Y0, and I know my origin is going to be at, what did I say, 7, 8. So the grid of the vacuum table can be used to your advantage if you do the installation correctly, you have repeat stops, and you understand where that vacuum table is installed relative to your machine. Would you suggest doing inlays hold downs using AirWeights, like holding down the male or female end grain panel? This is a great question. So I do recommend it. The key here is that you need to make sure that you account for the fact that end grain is so porous. I mean, end grain is literally like straws going straight through the thickness, and especially on those thinner plugs, you really start to see a significant leak rate, and the pumps are low enough flow rate that they just can't keep up. So the way that you mitigate that is you take painter's tape or masking tape and you just cover the bottom, and then ideally you use it in a direct mount approach or with a fixture plate, something that's fully sealed where you're not going to have any leaks, and you're effectively grabbing the tape that's stuck to the plug or the end grain block. So that's the key. Jeff from Two Moose does this all the time. We tested this at the Texas Woodworking Festival with our 17 CFM and a 24. We were able to get some pretty good results. And yeah, works, I'm sure, really well with the CIC workshop inlay kits. So good question. Fly formation. Would there be an issue running a 17 CFM and 9 CFM pump at the same time? So good question. From a pneumatic standpoint, ideally, you like to keep things equal, kind of all over the place. If you had them both running into a manifold and then the manifold plumbed out to the table, that'd probably be my preferred approach. Electrically, the thing I would watch out for is just current draw on the same circuit. Ideally, our pumps, especially in the 9 and 17 size, are on their own dedicated circuit. Both are available in 110. So I wouldn't run them on the same circuit for electrical compatibility issues. But from a functional standpoint, I don't think that you're going to have anything but a gain as long as you set up the pneumatics correctly. You want to make sure that, like, I wouldn't plumb a 17 on one side and a 9 on the other of the same table. I'd bring them into the same manifold and then have a single line going to the table just to balance flow, if that makes sense. Can we get longer pins? Yes. So great question. The 3/4 inch long pins that come in our hardware kits are meant for installation of our vacuum table. We also sell 1/2 inch long pin, or they come in the hardware kit, which is meant for locating accessory layers. But this fence demo that I did just now, just cutting a simple fence, I used 3/4-inch pins to reach from the vacuum table up through one accessory layer and into a second one. So those 3/4-inch pins are very common. 3/4-inch steel dowels, find them all over the internet. If you really want to, you can buy them on our website by just buying replacement hardware kits. But if you're looking for a specific length of steel dowel, you know, McMaster-Carr, Amazon, anywhere will have them. They're 1/4-inch dowels, and you know, whoops, everything okay? Okay, cool. Yeah, so find them on our website if you want, or check them out online. Sasquatch. Are the vacuum pumps 110-volt or 220-volt? Is there a 220-volt option? Currently, the only model that we have available in 220-volt is our 17 CFM pump. They're back ordered, and we don't expect them until mid-December as of this live stream. So typically, those pumps are targeted for international customers, and they're actually set up with an EU plug. So if you do want a 220-volt, you can purchase them, but it's going to be a while, and you would have to basically change the termination on the pump in order to plug it into your wall. And those also don't come from us with a remote accessory because they're 220, but there are some out there that are available, just so you know. Zim. Blue painter's tape will help with wormy maple or porous spalted wood. Yes, absolutely. So, ideally you want to put it on the bottom side if you can. In some cases, depending on the project and what you're cutting, you can put it on the top as long as you're not machining that area. If you machine it off, then obviously it becomes a leak path. So just think about where you need to put it to deal with holes. There are some extra wide painter's tapes that are sold, which is really nice for just like covering the bottom of an end grain plug or whatever. Wormy maple, for example. But yeah, the porous materials are challenging to work with just because you're not allowing for any pressure difference to build between above and below the part. How long is the cord on the 220-volt? Cord is only, I want to say it's, don't quote me on this. I want to say it's 5 feet. It's not very long. If I buy the 24x24 system and later decide to get a second 24x24, will the 5 CFM pump be sufficient for both boards? It's a great question, and it's a very common one. My recommendation on vacuum pump sizing is buy once, cry once. If you know you're going to expand in the future, then I would recommend just getting the bigger pump now so that you don't have to buy it later, and all you have to do is add a table. And a great opportunity to just mention again that we're running our Black Friday sale. So there is literally not a better time. There probably will never be a better time to pick up our products again. 20% off. The code is BFCM20. And it's a steal right now. Biggest sale we've ever ran. And yeah, I just think it's better to size up now and have the extra capacity and flow rate to grow with you. The other option is you can basically just tailor your work holding approach to the pump that you have. So if you're using a purely vacuum clamping approach, either direct mount or a fixture plate with gasket on top, there are no theoretically, there are no leaks. Obviously, in reality, there are some, just because you have splices of gasket, getting put together and things like that. But the aggregate leak is very, very low. And because the flow rate of the pump doesn't have to keep up with so much of a leak rate, a 5 CFM, like I used to make our tables on that machine over there with 2 24x24s and a 5 CFM pump. That's how we got started. And as long as you're purely vacuum clamping, you don't really care about flow rate. It's once you start to do downdrafting and using MDF spoilboards where the flow rate of the pump really starts to matter. And the pumps are paired with a given table size to maintain the capability to use our tables and our systems in a downdrafting method without losing performance. So use our products as a guide for what you can get away with. And also know that if you're committed to pure vacuum clamping using direct mount or fixture plates, you could probably get away with it. How long can the vacuum pump run continuously? Continuous duty. We run our pumps 8 hours a day, 5 days a week. And we've been doing, I mean, we're on the same pumps that we've been running for like more than a year now in this space. So, you know, it really is a continuous duty application. We have customers that run them 24 hours straight for long 3D carbs. And the key with the duty cycle is with these pumps, they like to be at deep vacuum. They like to pull against a sealed system. If you're running it wide open for a really long period of time, probably not the best for the life of the motor. So if you can get it to a point where it's just kind of maintaining the vacuum level and you're at really nice deep vacuum, like minus 20 plus, you're in a really great spot. And they'll just run and run and run. All of our pumps are also backed with a 1-year warranty. So you can feel confident running them.
Woohoo! Got through the questions.
Rapid fire.
That was a long haul. Good job, Jace.
Thank you.
Cool. Well, I think we can do the giveaway. I will put this on the screen. All you have to do is type #turkey in the chat, and you only have to enter once. And just a reminder, this giveaway is just for US customers. So yeah, go ahead and put your hashtags in the chat and we'll get this going. It looks like we maybe had one other question.
Yeah, you can put that up while people are entering.
There you go.
Yeah, so good question, John. Can you tell us your experience? Can you tell us what your experience is with how much you can cut into tiles, lifespan cuts, etc.? It really depends on your machine calibration and how confident you are, and how dialed in your setup is. So ideally, you cut through by the minimum amount possible, while you can, still getting a complete through cut, accounting for whatever Z height tolerance you have. But you just want to skim that surface so that any of those little tiny imperfections in the surface of the tile gasket get compressed out when the sheet sits down. So, industrial CNCs, I talk about this with All-Star a lot, and they have customers that get 500 plus machining hours out of a single set of tiles on a 4x8. But, that is not a hobby CNC. That's a, 4x8 steel frame, very, very well calibrated machine with extremely, extremely well dialed in Z heights, and a spoil board that's been faced and sealed, and checking all the boxes. So I would expect that if you're really well calibrated, you take your spoil board, you face it minimally to make sure that your Z height is calibrated really well for your given setup, and then you stick your tile gasket down. You can get quite a lot of cuts out of it. You just have to be cognizant of how much you're cutting through and make sure you really understand your depth of cut. Literally for the stock that you're cutting, like measure the stock, where you're going to set your zero, and then probe there, and then make sure your depth of cut is really dialed in.
All right. Well, we're at 55 entries. I think we could probably draw.
Yeah, let's see. Last chance. Any last turkeys? Oh, we got a couple turkeys in here. All right, what do you think, Kate? Should we do it?
Let's do it.
All right.
Woo-hoo!
Alex K. Woohoo!
Congratulations.
I like how on Andy Bird's podcast they have like a fake applause. We gotta get the fake applause going.
We should figure that out. Yes. So anyways, Alex, you can go ahead and email us at info@airweights.com and we'll get you all set up. You just need to send your name, your address, and your phone number, and I'll be in communication with you. I think we did mention that there is a lead time right now. So It might not ship out right away. We have a lot of orders to get through, but we will let you know.
Yeah, thanks, Alex. Please bear with us. It's free, so hopefully you're okay to wait. But we're excited to get this into your hands and hopefully help out your CNC journey and making parts more fun. So yeah, I did see one more question in the chat. I'm just going to answer briefly. Whoever that was that asked about mounting Onefinity QCW slats to a finished surface and not into the frame directly, just send us an email. There is a method for it. We've done this in the past where we make basically the mounting hole pattern for the Secure From Above version, which is a legacy product. And we can do that. It's just a customization thing. And we can also provide guidance on where you could actually just drill through right into a spoil board if you want a slats style format. So just send us a note and we'll be happy to help you out. Thank you everyone for joining our live stream. Always a great time and happy to share any knowledge I can with you. If you have topics you'd like to see in the future, please just let us know via email or in the chat for this video. And we really appreciate each and every one of you. I hope you learned something and thank you very much for joining us. Take care and we'll see you in the next live stream.